So good morning, good afternoon, and good evening, guys, based on the time zones you all are coming from. So before we get started, let me quickly introduce myself to you first. So my name is Neeraj Keria, and I've been working in this IT industry for close to 12 years now. Now, the main agenda for today's session is we'll be discussing on these topics. So first of all, we'll be starting our discussion on Python, what Python is, who exactly uses Python, what are different features available in Python, what are different operators in Python, what are the available data types, what exactly is entire flow control, the functions in Python, and how we can handle files in Python language. Now, first of all, let's start our discussion on. So good morning, good afternoon, and good evening, guys, based on the time zones you all are coming from. So before we get started, let me quickly introduce myself to you first. So my name is Neeraj Keria, and I've been working in this IT industry for close to 12 years now. Now, the main agenda for today's session is we'll be discussing on these topics. So first of all, we'll be starting our discussion on Python, what Python is, who exactly uses Python, what are different features available in Python, what are different operators in Python, what are the available data types, what exactly is entire flow control, the functions in Python, and how we can handle files in Python language. Now, first of all, let's start our discussion on Python itself. Now, Python, as you know, is again a high-level language. Python is basically called as a scripting language, right? Where it is a high-level programming language where we can say a dynamic semantics, right? So Python was created in 1989, and basically it is object-oriented. It is not process-oriented, right? So again, it is high-level language. It is easier to learn, and again, we have multiple procedures that we can define as a part of dynamic language altogether, right? And Python, as you know, is one of the main driving force for different companies, for different solutions all around the globe, for all around the globe altogether. It is one of the main driving force for the solutions built all around the globe altogether, right? So basically, if you talk about YouTube, now YouTube uses the entire sharing service is written in largely not exactly, or we can say not only in Python, but again, Python shares a good amount of percentage of the entire coded structure for YouTube. Google makes use of Python extensively in its entire web search algorithms. Dropbox, as you know, is one of the most popular service for cloud storage. Again, its entire servers and desktop client software, they are all written and driven by Python. Raspberry Pi, again, one of the most popular IoT devices, again, it simply is written on top of Python language altogether. BitTorrent, as one of the most we can say innovative solutions of the 20th century. Again, they have Python as a driving force for their peer-to-peer file sharing system. NASA, as we know, NASA uses multiple libraries of Python for performing scientific tasks and for performing the analysis on the image sets shared by their satellite systems. And then NSA uses Python for cryptography and intelligence analysis, whereas Netflix and Yelp both have documented the role of Python in their software infrastructure. That means these all companies are all driven by Python technology, by Python language as a main language for their entire background process, right? Now, why Python is most widely used language in different verticals? First of all, Python is the easiest language to start with, especially for those who are coming from non-IT backgrounds, because as compared to other languages, Python has the least amount of grammar. Now, when we say grammar, we simply mean, for example, if we have to write a simple print statement in Java, then we have to remember the syntax as in system.out.print or println, and then we can write the entire syntax there, right? Whereas in Python, we only have to write a simple English statement that is print, and then we have to define what exactly needs to be printed, right? So here there are no complex, we can say jargons, there are no complex terminologies or syntaxes that we need to follow as compared to other programming languages, making it much easier for, especially for those who are just beginning their career path in the programming world, right? And then again, it is free and open source. That means again, there are no licenses involved here for building on top of Python. Again, as it is available as an open source platform, right? It is again a high level language. That means again, one does not need to bother the low level details. That means memory allocation, for example, memory allocation. These are all managed automatically by Python itself, right? And then again, it is portable. That means it is supported by multiple platforms. It is not platform specific, right? So again, once written, it can be supported by Windows, by FreeBSD, by Solaris, Aurora. We have BOS, we have PlayStation, Windows. So we see again there are multiple platforms on which it is supported easily without any kind of hindrances. Right? Again, there are multiple paradigms that are being supported by Python. So again, if they have, suppose if we are combining this with multiple paradigms here, then we can do that easily as a part of Python altogether. It is extensible. That means again there are multiple libraries, right? And again, if possible, Python can also we can also invoke libraries of C and C++, right? So that's why it makes it easier for any application being developed or using some other components from other languages. They can also be well integrated with Python. Like we have Java and .NET components. These all are again compatible with Python using multiple libraries. Because libraries, again, there are multiple, there are hundreds of libraries available in Python, which are specifically designed for data manipulation, for development, for processing and performing different tasks. So that if we have any specific task that needs to be completed, then we can take the help of libraries. So in this entire example here, I'll be showcasing you the example for Python. We'll see the example for Python and how exactly it is used in the current scenario. PyCharm IDE. So PyCharm is available in two versions, right? PyCharm is available as a part of the enterprise solutions where we can integrate Python with other languages, like we have the support for HTML, for CSS, for JavaScript, and other components. If we are looking for a full-fledged development, or if we are looking to work only on the core Python without integrating it with other components, with other language and systems, then we can use the community version. Now, being a new developer here, guys, being a new new player in the market, we can simply go for community in order to understand the capabilities of Python of PyCharm. And again, if you are looking for a full-fledged development by integrating these components, then we can go ahead and download the professional version. Now, once we have downloaded and installed, and again, we simply have to click on download, and then we can configure the entire setup for PyCharm here, right? Now, once we have done the setup of PyCharm, we can simply open a PyCharm. So you can open it up to start working on a Python project. Now, when we start working on any Python project here, we can simply click on create project. So just a moment, let's wait for a second in order for that community version to be loaded again. So here we can choose the ID here. Here we can click on Python, and again here we can simply click on create, where we have all the entire internal and external libraries available here that we can use to get started. So let's start. So now first of all, let's see how exactly this has to be done here. Let us search for this library here. Now here what we have is, now here we do have another file created by the name of edureka.py, where we can define the, now there where we can start working on the entire library and skill set, and library is available inside this entire program code here. Now in here what we can do is, now here we can start working on top of the entire Python command. Before we jump into that part here, first of all, let's have a quick discussion on what exactly we mean by the operators and different components as a part of the entire course here. Now, first of all, we do have the concept of operators in Python. Now, when we talk about operators here, we do have multiple operators available in Python. Like we have arithmetic operators, we have assignment operators. Almost now the logic here remains same as of a Java course itself. Like we have multiple operators also available in Java, in other languages. Same way we have arithmetic operators. Then we have assignment, comparison, logical, bitwise, identity, and then we have, at last we have spatial operators altogether. Now let's see how exactly we can get started and get the output here. So now for doing that, what we can do, we can simply come back to our IDE. Now first of all, we have arithmetic operators. First of all, we do have arithmetic operators. In Python, we have simple terms that we can define here. For example, we can come back to our, okay, I think we accidentally closed that. So let's create a new project. In here now, when we are talking about operator, a simple operator here in Python, here we can simply define, suppose here we are defining x value to be, suppose 76, and then y value we want to define as 13, and now we want to define a simple print statement where we want to print x plus y. Then what we are doing, we are simply using a simple print statement to print the sum, or we can say we are using a simple arithmetic operator in order to print the given sum here. And again, in order to execute the entire sum here, we can simply right click on the entire program and click on run the program name. That is run in Edureka. And again, in here we can see the actual output given to us as 89, where we have simply used the additional operators altogether. Right? Same way we want, if we want to perform the subtraction or addition, whatever we want it to be, again we can simply right click on it, make the changes, right click, and again here we'll be given the output as well as a part of our entire arithmetic operators. Right? Now same way here we have main, or now here we can perform operations like we can add, we can subtract, we can divide as well. Suppose if you want to multiply these two numbers, we can simply go ahead and multiply and click on execute. Right? If we want to divide this, we want to find modulus of these numbers. Suppose let's say we want to divide these numbers here, these numbers, x divided by 5. Again, we can simply click on run, and then we can get the output of it. Same way, if we want to find modulus of this number, right? Same way here we can find modulus. Again, we can click on run Edureka, and here we are given the modulus of the number, correct? Same way, if we want to find the exponential, the floor division, then we can simply go ahead and use the entire value sets here, right? So that's why this is how the entire concept for arithmetic operators work in Python. Same way, we do have something as assignment operators. For example, let's say we want to make sure that one value is equivalent to the other value altogether, right? Then what we can do, we can simply go ahead and define this as a part of the assignment operators. For example, here we define x is equal to 76, and again here we define y. Now in here we define x is equal to and added the value of suppose 44, right? And in here we want to print the value of x. So again here what we are doing, we are simply defining x is equal to x plus 24. Now what this means is x is equal to x plus, it simply means x is equal to x plus 74. That means the initial value of x was 76. That means now this is 76 plus 44, and that is how much? 120. Absolutely. Right, so instead of writing this one here, what we can do, we can simply replace this with the assignment operator. So this will mean the same thing here as 120 here. Right, so again, that's why here we can define this for addition, for subtraction, for division as well. For example, if we make this as multiplication here, right? Suppose if we click on run, again we'll be seeing the output as in x is equal to x multiplied by 44, that is 33344 here. Now after arithmetic we have assignment operators, right? So as using assignment operator we can define multiple values without increasing the weight of the entire code, right? And then we have comparison. Now then we have comparison operators. So in comparison operators, we simply compare the values with each other. We simply compare the values of each other here, right? So for example, if we are trying to find, okay, if one number is greater than the other number or not, then we can use a comparison operator. For example, suppose if this would have been the value for y, and now if we want to compare if x is greater than 5, then what would be the return here? True. Why? Because x 76 is for sure greater than 44, right? And that's why this has been the value been given to us. And suppose if we change the operator in here, for example, if we want to check if x is less than y, then this will be returning false because x is equal to 76, and whereas 76 is in no mathematics book it is greater than 44, correct? And that's why we have returned a false statement altogether. Okay, let me showcase you this part here now. As you can see, currently we have defined each and everything in a separate line altogether, right? Suppose if we keep this on saying a single line altogether, can we see this? It simply says invalid syntax because again, why? Because again, this has not been interpreted as different statements altogether, right? And that's why here we have the given statement altogether, correct? Now, next after the comparison operator, we do have another operator available in Python. That is logical operators where we can define and, or not. Just like we use these in semiconductors as well. Same way here we can define and, or not as a part of the logical operators, right? For example, we want to check conditions. We want to check conditions here. What we can do, we can come back. In here we can define, for example, in here we want to check if x is greater than 5 and if x is less than 100, then only it should print the value as true, right? If we run this up, this is false. Why? Because x is not less than y, and although x is less than 100, this value is true, but again x is not less than y, right? Suppose if we change this to if x is greater than y and x is less than 100, then only it will return true because both the conditions have been fulfilled, right? But in here, if we define this, okay, if we change this from and to or, and suppose in here we again change the condition, okay, we want to check if x is less than y or less than 100. That's a part of the entire logical operators available in Python altogether, right? Same way here we have for and where both the conditions needs to be true, and in all statement only one condition needs to be true here, right? Next is we have bitwise operators. So bitwise operators they perform the OR operation on each bit of the number, and in here we can perform AND operations on R. We have A, B, and we have A and B, and we have A XOR B as well as a part of bitwise operators available in Python, right? And then we have identity operators. Right? Where we can simply define, here we can check the values. That way we can simply check the values here, right? So for example, if we had defined this as a part of statements, for example, if we come back to our console, let's suppose here we can define one array here. For example, let's say we add an array for car's name, for example, Mercedes. We define array as Mercedes, and then we have BMW, for example, Mercedes and BMW. And in Y, we define the same thing. Let's say we define the same thing the same array without any changes. The same array without any changes, right? And then we define Z should be equal to, Z is equal to X. Here we define Z is equal to X altogether, right? Now in here we can check, suppose here if we print, okay, if print x is z, and suppose in here we use print x is y, and in here we again we try to print here if x is equal to y. Now these are multiple statements, right? Now in here what we are trying to do is, now first of all we are trying to check if x is z, then here we have specifically defined, okay, z is equal to x, then this will return true. In here we are checking if x is y, that means although x, the value of y is equivalent to a value of x, but they have not been specifically defined, okay, they are equal to each other, correct? That's why this will return false. And in here what we are doing, we are simply checking the value. If the value of x is equal to y, then this will return true. That means if we simply execute this, we have true, false, true, right? Then these are multiple data types available in Python. Now in Python, we do not need to declare variables before using them. Just like we have been doing here in our console, where we don't need to declare, okay, variables as x, y, z, we can start using them easily without having the need to declare them, correct? And in here we have again the same concept as of Java as well. We do have immutable objects, and then we have mutable data types available. So in immutable we have numbers, strings, and tuples, whereas in mutable we have lists, dictionaries, and sets. Now in terms of immutable objects here, now first of all we have numbers. So strings are sequence of one character strings, right? For example, here we have small sample called welcome to Python tutorial, right? Or if we define or if we define a simple sample called welcome to Python tutorial, again these are again strings here, right? For example, now when we define strings, again we can write the characters, or we can add any numeric value to it as well. We can do both, right? Whereas if there are multiple strings that we want to add on concatenate together, then we can also do that as a part of the string operations. We can do that. Then in terms of the flow control, we have multiple flow control elements available in Python as well, where we can check for conditions as well. That means suppose if this condition is fulfilled, then only the thing should be executed, right? So again, and then if suppose if failed, suppose if condition one condition has not been fulfilled, then what's the other condition that needs to be fulfilled? Then we have if else. Again, if we have multiple conditions, then we can use if else. And again, if we have any particular loop that we want to iterate without being highlighted, then we can simply use for, while, break, and continue statements, right? So if we have multiple statements to check, we can simply use if else if. We can also use switch statement as well. So we have switch statement also available. So here we can also use switch elements as well. We can do that. Now, for example, suppose if we want to understand flow control in a much better way here, what we can do, we can simply go back to our console to check a simple statement here. Now in here what we can do, we can simply define the values here, right? So for example, let's say if we define a simple value as if x is suppose 99 and if y is equal to, let's suppose 22, right? Then in here we want to check if x is greater than y. If x is greater than y here, then what it should do, it should simply print one statement here, right? So again, it should simply print one statement. Okay. In here we can simply print the entire statements, and that is supposing if we want to print x is greater than y, then it should simply return x is greater than y, right? So, or the same condition is not fulfilled here, this entire thing will not be executed at all. As you can see, now this condition has been fulfilled here. Suppose if x is less than y here, again it will simply, first of all, it will check if x is greater than y here, it should return this value, this statement here, right? Or else if, suppose if this condition is not fulfilled, else if suppose if x is I suppose, let's say we change the value. Suppose that we change this to 11, right? Else if x is equal to 11, then it should print. X is equal to 11. As you can see here, if x is greater than y, this condition has not been fulfilled, and that's why here we have else, right? Or suppose if we have multiple conditions here, suppose else if, again we can be specific here, suppose if this condition is not even fulfilled, else what should happen? Else what should happen? Suppose if this even if this condition is not fulfilled here, we can define else. This should simply print better luck next time. Suppose in here, if these both the conditions are not fulfilled here, for example, run. As you can see here now, if both the conditions are not fulfilled, then we are getting the last statement here as a part of else. And suppose if you're looking for two-dimensional arrays here, we can simply suppose if we have an array by the name of suppose again cars. Now in here we want to add a multi-dimensional value here, right? We want to add one multi-dimensional value here. Again, it always has to be in double braces. It always has to be in double brackets, and then we can keep on defining this entire statement altogether. For example, let's suppose we have been defining suppose S class. In here, in order we want to define suppose for A8. In here for BMW, we want to define for 7 series. In here for Porsche, we want to define that suppose for Cayman. And now if we want to print the entire statement altogether, suppose in one go, then we can simply use the statement as print, and then we can simply start printing it one by one. And same way here we define these statements here, suppose as print, we want to print cars, and again in cars we have to define the exact index value altogether, right? Suppose in here from car we want to add to print Mercedes S class, right? So here we can define this as 0 and 0, because again Mercedes is stored at 0th block, and again S class is also stored at 0 block here. Suppose if we click on run, then we will be returned as a part of Mercedes and S class altogether. Alright, so here we can that's how we can start with the entire flow control statement altogether, and same way here we define the entire if and else as a part of the flow control. We have seen how exactly the if else statement works, where we can work with multiple conditions. If one condition is not fulfilled, then it will go to and check for the other conditions, and so on. Right, and next is we do have functions. We do have functions available in Python, where we can simply start creating functions one by one as simple function that can be triggered and executed as part of entire course here, right? For example, suppose if we want to want to create a function for adding two numbers, as simple as adding a two number, right? So first of all, for defining a function, what we can do, we can simply use a simple syntax called define, right? Where just like we write function in JavaScript and Java, same way here we can write define here, right? All right, so here first of all we have function here, guys. So for example, our main purpose is to add, right? For example, in here we are looking to add two numbers, right? So what we can do, we can simply define the function as define, and in here what exactly is a function that we are creating here. First, just like we define the function name, here we can define the function name here as well, and this will be add. For example, if we are creating a function for adding x and y, right? We can define the parameters just in the similar manner as we do in a JavaScript control, correct? Here we can define the function, and then we can define the variables as in what exactly we want to perform with this for this entire function here, right? So in here we can define, okay, we are looking to add, for example, if we are looking to add two numbers, then we can add then we can define x plus y. So for example, if we are looking to print z here, right? Suppose z should be x plus y, right? We are looking to perform this entire operation here, and then we want to simply print the statement for z. So here we can use return z, because again return will work same like a print statement altogether, correct? And then we have to define the input variables. That means again the user should be entering some digits here, and that for that purpose we can define, suppose let's see here, we can define num1 is equal to suppose 10 here, right? Or num1 or num2, or again being a variable here, is suppose 12, right? So here we have defined two numbers that we want to be added, correct? And now we can simply define the entire statement. Okay, what we need to print here, we need to print add function, and then we need to add what? We need to add num1 and num2 that we have defined here. So the function that we have defined here will be collabed with the variables that is being taken as a part of input variable, right? And if we go ahead and execute these, we'll be having the entire statement with this altogether as part of 22, as a part of the output for the given statement altogether. Thank you so much for joining, guys, and have a great day ahead. Take care. Bye bye.